In this video, we are going to discuss the different components of the nephron and specifically their functions. So in order to do this, I'm going to be going back and forth between slides so you can see images of what I'm just talking about, so it makes more sense. But please feel free to go back to previous videos and slides to refamiliarize yourself with these terms and structures. So we're going to start off with the glomerulus. So this structure is going to produce the filtrate. Like, this is what we talked about from the very beginning. And it's essentially most of the components of what's in our blood minus the proteins and the red blood cells. So it's a lot of the plasma, a lot of the components that are found in there. So water, waste products, ions, electrolytes, salts. So there's a lot of things that are found inside of this filtrate. So if I go back to the previous slides, this is what I'm talking about. It's the very beginning, the glomerulus, right? So it's that ball of yarn-looking structure that is just blood vessels, right? And they're encapsulated by this capsule. From here, we are able to remove all the filtrate, which brings us to the next part, which honestly I should say right here. The next part we're going to talk about is the proximal convoluted tubule. So it's where the filtrate is going to travel first. It's going to travel down this proximal convoluted tubule. Again, this is located in the cortex of the kidney. And it's proximal because it's close to the glomerulus. So what happens in the proximal convoluted tubule? Right here. The big thing is going to be resorption of sodium, potassium, and glucose. So this is an opportunity where, like we said, that filtrate has all these components from the blood. This is the first opportunity that our kidneys have to bring back these components that it needs, right? So again, talking about the refrigerator example. First we emptied the refrigerator. Now we're going to start putting the things we want back into it. So we are going to reabsorb these components as well as chloride and also water. So we're going to bring these back into our body, back into our bloodstream. What we're going to secrete or remove are things like certain drugs that might be in our system by active transport. So in other words, we're going to take these other components that we no longer need and we can secrete them into the filtrate, which will eventually leave the body. So if we secrete something, we're putting it into the filtrate to leave the body. If we reabsorb something, we are reabsorbing it back into our bloodstream. And once again, from the previous video, what does that look like? Again, if you look at all these tubules, you will see all these capillaries surrounding the tubule. So for example, right here at the top, capillaries. They're able to reabsorb what we want from the filtrate that is in the tubule, which I'm drawing in blue. Right? So we can reabsorb that back into the capillaries. The next part is the loop of Henle, which is going to be used for very similar functions as you saw from that last slide. Here's the loop of Henle. I'm going to draw in purple. We have the descending loop that goes down into the medulla, and it loops back up into the ascending loop, which goes back into the cortex. So this is the loop of Henle. And like I said, similar function in the loop of Henle. Lastly, we have the distal convoluted tubule. The distal convoluted tubule is exactly that. It's distal. It's further away from the glomerulus. As you can see in this slide here. The distal one is in purple. So the loop of Henle, I will draw in purple. The loop of Henle, the filtrate is going to go down and then back up. And once it reaches the cortex again, it will enter the distal convoluted tubule. Here, you will see reabsorption back into the bloodstream of sodium. That is the primary focus of the distal convoluted tubule. We're going to reabsorb sodium back into the bloodstream. We're also going to secrete additional hydrogen and potassium ions as needed, so we can make sure that our filtrate is exactly that. It's what we're filtering out. It's going to become urine, and we can make sure we reabsorbed everything we wanted back into our bloodstream. Lastly, we have our collecting tubules, which I'm going to draw here with blue. So once the distal convoluted tubule reaches the end, it's going to go into this collecting duct. This collecting duct is going to empty out into the calyx, like I mentioned before, which is going to be your urine. Right from here, the calyx is going to empty into the ureters, which will go down into the urinary bladder. So does anything happen here? Yes. This is the last time that our filtrate has a chance to be reabsorbed back into the bloodstream, specifically water. So if our body needs to reabsorb water back into the blood, it will happen here at the collecting duct. It's our last opportunity to collect water. One of the hormones that we've discussed before, and you will see again, is ADH, antidiuretic hormone. And this is also going to be a really important hormone that works with the collecting tubules to reabsorb water. So this is one of the hormones we use for a negative feedback loop to maintain our water homeostasis. It directly influences the collecting ducts and resorption of water. At this time, if you have any questions on the functions of the nephron, please let me know.